Scientific Officer of Economic Cooperation Organization, Science Foundation, ECOSF, the World Bank Energy Efficiency Consultant, and National Technical Expert, Electric Mobility UNDP Pakistan, and his speech entitled on low carbon transportation in BRI countries. Let's welcome.
Just confirm that you see my slides okay.
Yes, we can see you.
All right. So thank you again. And good morning and good afternoon, depending on the location you are at. So my name is Raza, and I'm a scientific officer at the Economic Cooperation Organization Science Foundation. So the title of my talk is Decarbonizing the Road Transport Sector. And the outcomes or the findings or the results that I would show during my presentation it's based on a project that we collaborated with the UNDP to help support government of Pakistan in scaling up the electric mobility in Pakistan. So ECOSF and provided technical support to the Ministry of Energy through National Energy Efficiency Conservation Authority. And so in the initial part of my presentation, I will talk about the global landscape of the electric mobility, and later on I would focus my presentation on the Pakistani national landscape and market analysis. Just a second. All right. So this is the outline of my presentation. As I said, I'll briefly talk about the net zero plan and the role of road transportation. How do we achieve the net zero plan by 2050? Then I'll talk about the policy, vision and goals, the global trends, the lithium battery industry, the metrics that we can measure the progress in terms of transition from internal combustion engine to electric vehicles, the impact of electric mobility in reducing the greenhouse gas emissions, the EV charging infrastructure, and the electrical infrastructure supply that would help power the EVs. And finally, I would talk about the economics of EV charging stations and conclude my presentation. So, as you can see that the transportation has the biggest source of greenhouse gas emissions. And the biggest culprit are these greenhouse gas emissions. And in order to reduce them so that we avoid the devastating impact of climate change, there are multiple sectors that contribute to this. So among this, the energy sector contributes the most, over 70%. And among them, the buildings, the transport sector, and the industry sector. So previously, over the course of this training session, particularly last day, esteemed experts gave a precise overview of how we can reduce the greenhouse gas emissions in the industrial sector. So my presentation would focus on the transport section that almost contributes to over 17%. And in that 17%, if you could see on your left, it is the global CO2 emission from the transport sector. The road transport sector contributes to over 45%, whereas the freight, that the heavy trucks and trailers, they contribute to over 30%. Whereas aviation and shipping industry, they contribute roughly about 20%. So most of the sector's emissions come from road transport that convey about 90%. And in order for major decarbonization to take place, there would have to be some pathway for transportation. And the major intervention that would include are the electric mobility, electric vehicles, switching to low carbon fuels, improving vehicle efficiency and system-wide efficiency. So this is a plan by International Energy Agency, and as you could see, so in that plan, over 60% of the global car sales by 2030, if we want to achieve this plan, that is in line with the 1.5 degrees Celsius, we need to achieve 60% of global car sales of electric vehicle by 2030. And by 2035, there has to be no new internal combustion engine car sale. So by ICE, I mean internal combustion engine. And by 2035, again, 50% of the heavy trucks would have to be electric so that we could achieve a plan. And 50% of the fuels used in aviation should have to be low emissions. So this is a pretty ambitious plan. And although the transport sector offers a great, powerful opportunity to achieve this positive change at a global scale. Now, the important challenge that we need to address is that we need to improve the quality of mobility for all, which is an outcome that we should pursue as a part of decarbonization. So this is a global EV market. On the left, you see the addition or the penetration of electric vehicle as a share of the total car sales, and on your right, you see geographic maps that those countries, those who have achieved significant progress over the last decade or so. So electric vehicles are pretty old technology, but the limelight about for the electric vehicle came about a decade ago when the technology was finally mature enough, because the economics of this technology has improved, massively improved, and today's EV electric vehicles make complete economic sense across multiple use cases. So if I can quote the IEA statistics about the sales of electric vehicles doubled this year from the previous year to a new record of 6.6 million. And now, if you could see that back in 2012, just 120,000 electric cars were sold worldwide. In 2020, more than that, many were sold each week. So nearly 10% of the global car sales today are electric. That is almost 4 times the market share in 2019. So the total number of electric cars on the road today are about 16.5 million, which is the triple the amount of this car sold in 2018. Now, if we look at the who is dominating or who is the leader in this market, China seems to be at the top. They have moved way ahead in the EV adoption case, and over 50% of the share of the global electric car sales. So more cars were sold in China in 2021, almost like 3.3 million than in the entire world. So this brings us to understand as to what are those key drivers of electric mobility market worldwide. So I've compared the 4 major economies, China, US, India, Europe, against Pakistan, with the key drivers. Number 1 is the zero emission vehicle targets, the average vehicle fleet emission targets, that is measured in grams of CO2 per kilogram. Then the fuel economy standards, that what should be the optimum utilization of fuel in terms of its productivity, liters per 100 kilometers. And the third one is the how do we plan for the phase out of internal combustion engine, as I earlier mentioned in the previous slide, that by 2030 and 2035, there's a complete phase out of internal combustion engine. That's if we want to achieve it. And lastly is the EV purchase incentive. So if we look at the zero emission vehicle targets, China, US, India, Europe, they all have distinctive targets assigned for their transportation sector. So for China, it's 30% of the new sales of the EV by 2030. US wants to sell over 3.3 million EVs. Similar, we have figures for India and Europe, whereas for Pakistan's national electric vehicle policy, the target is to achieve 30% of new sales of EV by 2030. Now, it's important that, so there are two, these regulatory, like average vehicle emission fleet and fuel economy standards. These two are directed at the manufacturers. These are the targets, or these are the standards established for the manufacturers, for the car manufacturers, which forces them to produce efficient cars. So, for instance, in China, the target is that the per kilometer emission of any car should not be beyond 117 grams of CO2. Similarly, for US and Europe, that's ranged between 93 to 95 grams of CO2 per kilometer by 2021. Now, it's interesting that although these are regulations, but the strict regulations are being followed or adopted by Europe. For each gram of CO2, if the car manufacturer does not achieve this target, they will have to pay a hefty amount of about 100 euros or something. By all the, if you just take the total number of, like, there are millions of cars produced, and any company, let's say Audi, they are not able to meet this target. They will have to pay this hefty price of 95 grams of CO2, and that is the major driver that is changing, or that is transforming the automotive sector, because there are physical limits where you cannot achieve much high efficiency. So the option or the alternative is for the manufacturers to switch to electric vehicles. Similar is the case with the fuel economy standards. And then there are the other two targets are the regulatory targets targeted at the government or the policy support. Let's, for instance, phase out of internal combustion engine. Like USA, they have this target for 2050. For Europe, the Netherlands, Ireland, Denmark by 2030, and for France, Spain by 2040, and Germany by 2050. Pakistan, unfortunately, we do not have yet the except the zero emission vehicle targets. The four we are still working on, and the top priority for Pakistan should be that we need to develop the fuel economy standard, because we heavily rely on fuel imports. And the last one, the EV purchase incentives, that's the key driver, and that is directed at the consumers. So each government, because there's a substantial difference in the price, so roughly about 30%, the EVs cost 30% more than a conventional internal combustion engine. To bridge this price gap, or to reduce that price gap, multiple economies and countries, they have provided these purchase incentives. For instance, China, they started with $3,200 with the maximum price of EV. If the car stands at the car price cost at $42,000. Similarly, US provides tax credits up to $7,500. India also provides some purchase incentives, and Europe has a range of from $2,000 to $7,000. So these are a number of the benchmarks or the drivers that are transforming the electric mobility, and they are accelerating the transition to EVs. So as you could see, just Pakistan has this zero emission targets, but we still have to work on the rest of the four key milestones to achieve the EV policy targets. So in terms of subsidy, the US has a plan to inject about $174 billion. That's the recent pledge by the Biden administration. So far, China has already invested about $60 billion, and that's the annual subsidy accounts to about $1.4 billion, where India has so far injected $1.4 billion to upscale to gain substantial momentum, because at this particular time, the market is not mature enough. So we need to provide some incentives so that the market could take it up, on its own. So this is the what has to be the policy vision for e-mobility. There are a number of factors. So the policy has to reach out to each one of those actors so that the outcome is productive, and then we could achieve the intended targets or goals. So this starts from the EV battery manufacturing, cell manufacturers, the grid planners, the charge operators, the public charging, infrastructure. Then there are OEMs, customers, retail, public transport, and fleet. All these have to be, incentivized or given a policy framework in a way that all these actors work together in a way that the ecosystem is developed and the intended targets are achieved. So among all these, I believe the OEMs play the biggest influential role at the initial phase, because the OEMs have to provide supply adequate models that can meet the market demand. But at the same time, the government and the regulatory authorities need to provide the strong framework or the robust framework where these vehicles, products are being sold in the market in the market fashion, and whereas the grid or the electric supply chain is adequate enough to support this transition. These are some of the policy incentives that were given to the EV value chain when the National Electric Vehicle Policy of Pakistan was announced. There are two different categories of beneficiaries in that. One are the completely knocked down CKD suppliers, and other are the completely built unit suppliers. So completely built unit is that the entire manufactured model is imported in its furnished form, whereas the CKD, the parts are imported and they are assembled locally in Pakistan. So I won't get into the details as to what are those in the custom duty and sales tax, but the government of Pakistan seems to have given a reasonably good incentives, but it depends at how far these are implemented on the ground. So in terms of those were the drivers. So what are those key factors that will help adopt and scale up the electric mobility in Pakistan? We believe that these are the four areas where any country in the world needs to work or needs to provide substantial support to help gain the momentum in the industry. So number one is the policy support. Policy support through subsidies alone might not be the most effective tool for large scale production. So there can be two scenarios. One is we've just given the mandated adoption targets, like there's a zero emission targets, or there's a clear policy framework and support through incentives. If that is given due support, I believe that policy is the biggest influential role in this entire arrangement. The next is the battery cost. Battery cost is the single largest constraint for EV economic parity at the moment, because as I said, that the electric vehicles cost 30% more than conventional vehicles. So it's hard for a consumer to go or to switch to EV if that price differential is high. And this automotive industry is quite cost sensitive, and the consumers are pretty the decision making by the consumers rely on the purchase cost of the vehicle. So we understand that the battery price, that this 30% differential is contributed by the battery price. So if the battery price continues to go down, and if it comes down to 100 kilowatt hour, this is what we believe, this will be the tipping point where the price parity between EV and internal combustion engine we could reach, and there the consumers would have the choice to directly switch to an EV rather than internal combustion engine, because of multiple benefits, because it can save fuel, it can emits less emissions, etc. The third one is the charging infrastructure. We believe that the good public charging infrastructure, especially for the four wheels, is critical. The quick transition to electric vehicle would depend on the amount and the readiness of charging infrastructure. Now, charging infrastructure is also important from the perspective that it provides kind of a psychological push, that even if the consumers could see that there are enough charging infrastructure, there could be an easier rollover to electric vehicles. So charging infrastructure mainly breaks the barrier. For instance, if the policy is there, the battery prices are down, the people could afford the electric vehicles. The next thing that hinders for a consumer point of view, they would consider whether there are enough charging infrastructure in the city, in the town, and location there, whether for their easier transition. So this is what it's important. The last one is supply chain evolution. For instance, how much of that supply chain that includes the motors, body parts, the battery manufacturers, we can locally supply those critical elements or the critical components. If the components get localized for 80%, if 80% of the components are localized, we believe there will be significant uptake, because this would achieve the economy of scale pricing momentum, and thereby reducing the overall cost of an electric vehicle. This demonstrates the lithium-ion battery industry. So right now, over 800 gigawatt hours of battery capacities, that went into EV production last year. The critical challenge is the availability of battery raw material. So this graph shows the total lithium-ion battery production capacity in the world, where on the top right, you see the critical supply of this raw material, who contributes in terms of lithium. Like there are four critical elements: lithium, copper, cobalt, nickel. In terms of lithium, Australia has the greatest share in terms of the production. Then there's Chile, Peru, and lithium triangle. For cobalt, cobalt is mainly extracted from the Republic of Congo. Similar is the case with the nickel. But interesting part is that although that these raw materials are not entirely located in China, but in terms of, if you could see this bottom right figure, so in terms of upstream mining, China has only 23% of its capacity, but when it comes to refining those critical materials into finished products in terms of cell manufacturing and cell staking, then midstream production of cathode and anode. So China dominates the chemical refining and cell production. So midstream, 80% of that chemical refining is done in China. And whereas for cathode and anode production, China contributes over 66%. And for downstream, in terms of refined lithium cells, over 73% of that production comes from China. Since China, as the flag bearer of the Belt and Road Initiative, it can help many countries in this region to help support the EV transition in terms of providing these critical metals, as well as these elements such as cathodes and anodes, and finally the lithium-ion battery cells. So on the bottom left, you see the lithium-ion battery pack price in dollars per kilowatt hours. So in 2010, the dollar per kilowatt hour cost of that lithium battery costed us at about almost 1,100, and it has sharply reduced to less than 150 in 2020. And as I said, if it drops below to $100 per kilowatt hour, this would be a tipping point for the industry, where the price parity we would achieve between the electric vehicle and ICE vehicles. And if that is the trend, we expect that by 2025 or 2026, we would expect this transition would scale up once the battery price goes down. So this is the current composition of automotive market in Pakistan. For the two wheels, the bikes, motorbikes, they contribute about 76% of the market, followed by four wheels and auto rickshaw. So over 29 million units are currently sold, or the total number of registered vehicles in Pakistan, whereas for the passenger vehicles, the sale exceeds over 2 million. And over the period of about 9 years, the two and three wheels vehicles have recorded a very high annual growth at 17%. That's the reason that motorbikes and two-wheelers are the important consideration in the EV policy, because they consume about 50% of the total fuel usage in the country. And consequently, because of the higher sale of motorbikes, they have corresponded with the higher consumption, and the petrol consumption recordings are at about 23% year-on-year rise, which is, if this trend continues, the import bill of Pakistan would continue to shoot up and at sustainable levels. And Pakistan is already facing, the economic crisis. I think that this electrification of road transport sector is one of the key elements that we can bridge in to address our both the transportation and economic challenges. So in that study, we conducted a total cost of ownership. It's a metric to compare various electric vehicles with the internal combustion engines. So the total cost of ownership, or the TCO in short, it offers valuable insights for decision makers in various roles. For instance, for policymakers, the TCO analysis offers evidence to design the right size charging infrastructure or the financial incentives to spur EV adoption. For instance, through this analysis, we have identified or demonstrated that the biggest advantage of switching from internal combustion to electric vehicles would be achieved through two and three wheels. So for policymakers, it's quite significant for their decision making to which segment of the market they could target. Similarly, for fleet operators, for instance, those who operate buses and taxis and Ubers or Kareems, etc., the TCO analysis is important for them to provide an assessment of economic viability to support a business transition towards electric vehicles. For instance, we have also demonstrated that the commercial viability of electric vehicles is much higher than personal vehicles, because the commercial viability increases, or the feasibility is much attractive if there are more miles driven by a car. And that's the reason that the commercial vehicles are more suitable for at this stage. And for consumers, it's also important that TCO can support purchase decision. For instance, if someone wants to purchase a four-wheel vehicle, whether it would save in the long run over the total lifetime of that vehicle, whether consumer would save enough amount, or whether it's an attractive choice at the moment or not. So these are important. So these are TCO analysis, for instance, electric two-wheel versus internal combustion engine two-wheel. So if you see that the green is the capex, that's the purchase cost, and the blue is the petrol cost or the fuel cost. So in terms of a motorbike, you see there's a significant cost savings. Although internal combustion engine has lower purchase cost, but it has significantly high fuel cost. So the total cost of this two-wheel, it's less than around 200,000 for the entire period of its life. For this analysis, we conducted the timeline for about 5 years, and for that you see a significant savings during that period of time. For three wheels, there's again three wheels of the rickshaws. Rickshaws, I don't know, they are common public transport mechanisms or in some part of the Asia, but I don't think that whether China would have them. I've never experienced that. So even the three wheels offer significant potential. You could see that in terms of the purchase cost, the electric vehicle is almost twice the cost of internal combustion engine, but in terms of fuels, we would save significant amount. Similar is the case with the internal combustion engine four-wheel MG motors of EV versus and four-wheel electric. You see, there's not much difference. Yeah, but if you can run that for personal use, it's not going to save enough amount of money. It's not an attractive option at the moment. But for a commercial purpose, this could save a lot of money. Similarly, the TCO is attractive for buses, but because the purchase cost is quite substantial, then there is a need for policy incentives in terms of purchase subsidies by the regulatory authorities, the municipalities, or the city administration to help support the purchase of electric buses. So based on that, we have demonstrated that two wheels makes the most economic sense, followed by rickshaws, then buses, then commercial fleet, then heavy commercial, and the retail or the personal cars. So, this is a significant outcome where the policymakers can target their subsidies in a way that this can, and if we just able to provide subsidy or regulatory support for two-wheel bikes or the buses, can have a significant impact in terms of reducing the fuel imports as well as emissions in the locality of the cities and towns. So we have tried to project the EV penetration under three different distinct scenarios. If the penetration is at high level, at the moderate level, or at the medium level and low EV penetration. So as you could see, the first input of our model is the EV penetration rate through 2030 that we assumed as shown in this table. On basis of that assumption, we calculated the annual and cumulative number of EVs on the road, and then projected EV related electricity and power demand So subsequently, these projections drove our estimates for both EV-related electricity demand and fuel savings. So in terms of high or aggressive EV penetration, we believe that it would happen. The assumption is that it would happen if the price of the battery comes down to $100 per kilowatt hour in 2024. And after that, by 2025, we see that there will be a significant uptake. In terms of the moderate EV, we have assumed that the price penetration or the price point where the $100 is achieved is marked or achieved towards the end of this decade, maybe around 2028 or 2029. That would have a lower penetration of EVs. Where in the low EV penetration scenario, we assume that this is a business as usual, and the market price of lithium ion would continue to remain same as it is of today, and that's how there will be the lowest penetration. So after modeling the penetration of EVs on a different scale or scenarios, that's high, medium, and low, we projected the demand that it would create or it have on the electric grid. In high EV penetration, we believe that the total demand by 2030 of the cumulative EV penetration would not go beyond over 7,500 gigawatt hours. That roughly translates to, in terms of power capacity, about 1,700 to 2,000 megawatts. Now, this is quite significant in terms of that even if we achieve 30% of the new sales of electric vehicle by 2030, the demand would not be substantial. So this coincides with the worldwide experience, which suggests that the projected growth of electric vehicles will not drive substantial increase in the total electricity demand. And we have also seen, for example, in projected EV growth in Germany would only add about 1% of the total electricity demand. Same is the case with the US, as S&P Analytics Outlook suggests that the total demand would not be over 2% of the total electricity demand. So although on a national scale, that 17 to 2,000 megawatt does not seem big, but it would have a substantial impact on the local grid. It would reshape the electricity load curve. And for instance, what will happen if all the EVs charge at once? So this would collapse the local grid systems. So for that, we need to have some innovative technology and solutions in terms to leverage technology with smart chargers, energy storage, and vehicle to grid. And we also need to add a substantial amount of grid strengthening to help support the distribution companies in terms of maintaining the lines, transformers, and switch gears. And so we have to identify those pockets or areas of the grid distribution companies where there will be highest adoption of EVs and subsequently manage a distribution load. This slide shows the fuel savings and greenhouse gas mitigation. So in terms of overall road transport, that's account for 92% total emission from the transport sector. And so if we take into account that over 40 million tons of CO2 equivalent was emitted by the road transport sector, as it was documented in the second National Communication on Climate Change. So about 10% of the total CO2 of the total GHG emission can be mitigated and reduced through adoption of electric vehicles. In terms of fuel cost savings, if we are able to achieve high EV penetration target, that's the 30% of the new sales of electric vehicles, we could save about $12 billion in the next 10 years. And in terms of medium EV penetration, this figures comes around $7 billion. Even with low EV penetration, there is a substantial saving of $3.1 billion. But the important point here is that for this to happen, although we would be able to save, fuel imports, but at the same time, we have to localize. As I said in my earlier slide, that the success of this transition depends on how quickly we can localize the different components, body parts, and etc., so that we could manufacture. If we are not able to, import, or we are not able to localize the EV value chain, there will not be a significant, achievement, because although we might be able to save about $12 billion in fuel imports, but we might have to add or import similar amount of, financial outlay by importing critical components. So that it's important that we need to localize our EV value chain. So for EV charging technology, there are various levels where we can, plug in our cars. So level 1 corresponds to the residential. It draws up to 3.3 kilowatt, and it can easily be integrated at domestic places, shops, commercial spaces, where you can generally add level 1 charger without going into, significant expansion or in terms of modification of the electric circuits. Whereas level 2 is more of a sophisticated, it takes about 3.3 to 22 kilowatt. This is where the commercial chargers begin to open up. And so ideally, this is suited for commercial businesses and workspaces, and it has a pretty, in terms of level 1, it has quicker charging times, whereas the level 3 DC fast charger, as the name denotes that it's a fast charger, comparatively fast, and they range from 330 to 350 kilo. So for Pakistan market, I think depending on the market demand and as well as the supply of the electric infrastructure, we believe that the level 2 that ranges from 3.3 to 22 kilowatt would be the dominant charging point for most of the car owners at the commercial spaces. For DC fast chargers, you would require pretty fast amount of charging at the highways, at the motorways or interstate corridors, because at that particular route, consumers usually do not have much time to spend, because even if at the commercial level too, a typical electric vehicle would require 4 to 5 hours to completely charge the vehicle. But usually there would be an adoption of a kind of a consumer learning curve, where they do not need to charge the car to electric vehicle to full, depending, because just a 20 minutes of AC level 2 charge would be good enough to get you from point A to point B. But if those consumers, those who have an access to charging level 1 at their garages or at their homes, domestic, where their cars are mostly parked at night, they can plug in their car for the entire night, and their car would be good enough to get charging. That would help them travel to over 300 to 400 kilometers. That's a good enough mileage that one can get in a week's period of time. So for EV charging, the important consideration is like how many chargers do we need, what kind of chargers do we need, and where do we need to install those chargers. And in some cases, these chargers may not work, and the battery swapping, that's another mechanism where the batteries can quickly be replaced by already charged points, where the consumers would just go and quickly swap their batteries with they would switch on the empty batteries and replace them with the fully charged batteries at the charge depots. So these are one of the. So in terms of demand, you see in China, the demand mostly comes from the public charging. So the gray is the public charging, blue is home. Because China is a vertically developed country where most of the residents stay at their apartments, or there are not much detached houses. So because of this reason, there is a much demand of the public charging that comes from. Where in terms of Europe and United States, you see most of the charging demand comes from home, because the population or the demographic is designed such that they have, in majority of cases, they have detached houses, so they can charge their home. But so Pakistan's would remain at the midpoint. For instance, in Islamabad, most of the urban locality have the detached houses, so home charging might be a feasible option. But in terms of, if we look at Karachi, the public charging would be most feasible option. And same is the case, as I said, that level 2 public charging. So the blue is the fast charger, DC fast charger. Gray is AC level 2, and that blue is the level 1 charger. As you see, that level 2, that's 3.3 to 22 kilowatt, that's the dominant charger elsewhere, even in China and European US markets. So we would have similar kind of market transition in Pakistan. And in order to have a quick adoption and to have a reliable charging infrastructure, it would be important that we have an EV charging infrastructure that is adequately planned, that covers the most coverage, but it's not over expanded, like in terms of what we have seen in case of the CNG market that emerged in early 2000s. So that the planning was not due enough so that we could understand how the market would evolve. But for in this case, we need an adequate level of planning so that we can understand the market dynamics, so that we are not over planning and not also getting short of what the market needs. So this slide shows the charging utilization gap, because at the early stage there will be a utilization gap, because there's a chicken and egg situation, that there are not enough chargers at any location, and there's also a consumer behavior that since there are not enough chargers, I cannot switch to EV. So for that, this utilization gap has to be filled by the regulatory authorities, the municipalities, and the cities. And for this, the government would have to step in and provide some infrastructure support in setting up the EV charging station at some identified hotspots. These are charging plug standards. So currently we have 4 or 5 different standards in terms of ACs and DCs. There's a North American standard, Japanese, European, Chinese, and there's a Tesla. For our proposal has been that for AC charging, Type 2 Euro port, because Pakistan has already a European, the grid that operates here is at the European level. And similarly for DC charging, we recommend that CCS2 connector is the possible candidate for the Pakistan standard for DC fast charging. So this is an area where we still need to do a lot of work, which is to improve our regulations and standards around the charging infrastructure. So we also need to develop the set of technical standards and safety precautions that govern the EV charging system. This would help ensure that the transition to EV market is safe and reliable for the consumers. This is pretty complex slide in terms of it shows the economics of EV charging stations. So we have plotted the cost of charging for various chargers as well as for the hybrid vehicle. So you see this line is the cost of an fuel this is the cost of a running an internal combustion engine that is Honda Civic equivalent for the fuel efficiency of 10 kilometers. We have plotted this against the various chargers. So this is green is the residential chargers. This blue is the residential peak, and then we have this level 2 chargers, level 4 chargers. So as you could see, the charging utilization is the key to help enable the or to sustainably acquire the economics of the EV charging stations. So any of the charger that we have proposed in terms of either it's level 2, level 3, or level 4, the economics depends on the charging utilization. If the utilization of any charger is below 10%, they are cost competitive than the petrol price. For instance, if you have to compare with the internal combustion engine that costs you 62 rupees, if you would have to switch to EV, this would have costed you at the level 4, even which is the highest 150 kilowatt pretty fast charger, it would cost you about 55 rupees Pakistani rupees. So none of these chargers can meet the residential off-peak. So this is the best strategy that the most economical option for charging an electric vehicle is at home and preferably at night. So this is a regulatory framework for EV charging station. This is perhaps more relevant to Pakistani context, so I'll skip this. But in terms of conclusion, these are broad conclusions, and as I said, that the number one or the most influential factors in terms of helping Pakistan and other regions is to localize the key components. So for them, they need to have a strategy for making their local countries, and for Pakistan, it has to be a make in Pakistan. The EV parts need to get localized in the country, and for that, we need to establish a strong collaboration with China in terms of securing the supply of key raw materials, the components, the anode and cathodes, and help support the local production of the batteries and lithium-ion cells. As I said, for Pakistan, which heavily relies on the fuel imports, it's important that we have established the national fuel economy standards for all automotive manufacturers. At this moment in time, we do not have such regulation, but this is the key to help support the transition, not just for electric vehicles, but other energy efficient road transportation. So this would reduce the energy intensity of road transport sector, help decrease the oil imports, and increase energy security and help protect the environment. Then for charging infrastructure, we have to provide adequate and reliable supply of power for e-mobility. For that, we need to create the grid and distribution networks, employ innovative mechanisms such as time of use to manage the power loads, and diversify power mix, that we have much of the renewable energy coming in, and renewable energy, as in my previous speaker, he demonstrated that solar is the cheapest at the moment. If we are able to integrate maximum renewable energy into our grid, the overall cost of energy would go down, and similarly, this would translate into lower cost for fuel transportation or the electricity transportation for charging electric vehicles. Lastly, the overarching regulatory framework is very much important to streamline the development of EV charging stations across the country, and we need to have this for the entire value chain, starting from the automotive manufacturers, for charge point operators, for the critical raw material importers, and then refining and producing them locally. So we need to have facilitate one window operation for EV charge point operators, and as well as other automotive manufacturers. For that, we need to define clear permitting, licensing, and approval procedures for setting up an EV charging station. So that's all for now, and I welcome all if you have any question and answers.